Nikola Tesla and 89 Liberty Street. Part 2.
The Serb was mysterious. He could rebuff lesser mortals and enjoyed the habits of a recluse.
But Thomas Comerford Martin had tact and tenacity of purpose. He helped arrange for the esteemed engineering professor William Anthony of Cornell University to come to Liberty Street and test the new AC motors for efficiency.
And Tesla reciprocated by traveling to Cornell to display his motors to Anthony and 3 other professors: Ike H. Thurston, Edward Nicholas, and William Bryan. Anthony, who was 20 years their senior and a graduate of both Brown and Yale universities, had just retired from Cornell after 15 years in order to take a position designing electrical measuring instruments for Mather Electrical Company in Manchester, Connecticut.
Soon to be president of the ALI himself, Anthony was pleased with his tests. Along with Martin, he helped coax Tesla into presenting his motor before the newly formed Electrical Society.
Martin had great difficulty persuading Tesla to give any paper at all. Martin said that Tesla stood very much alone, as the majority of the electricians were entirely unfamiliar with the motor's value. In haste, Tesla wrote out his lecture the night before in pencil. It had not been easy for him to construct an efficient machine, but having finally succeeded and having passed all of Professor Anthony's stringent tests for efficiency, nothing now stood in the way of its commercial development, except that they had to be constructed with a view to operating on the circuits then existing, which in this country were all of high frequency.
On May 15, 1888, Tesla appeared before the AIE to read his landmark paper, New Alternating Current Motor. He had already filed for 14 of the 40 fundamental patents on the AC system, but he was still reluctant to fully announce his work.
Realizing that the invention was worth at a minimum hundreds of thousands of dollars, Tesla and company sought investors through the advice of their new patent attorneys, Parker W. Page, Leonard E. Curtis, and Jen Samuel Duncan, the last a leader of the firm and respected member of the New York Bar Association. By the time of the lecture, Tesla, Peck, and Brown had already been negotiating with prospective buyers, such as Mr. Butterworth, Argus manufacturer from San Francisco, and through General Duncan, George Westinghouse of Pittsburgh, but nothing as yet was settled. Westinghouse was already utilizing an alternating current system developed by the erratic French inventor Lucien Gollard and the sporty entrepreneur John Dixon Gibbs of England. In 1885, his manager of the electrical division, Guido Pantaleone, had returned to Turin, Italy, to attend the funeral of his father.
By coincidence, through his engineering professor Galileo Ferraris, whom Westinghouse himself had met while visiting Italy in 1882, Pantaleone was introduced to Lucien Gollard, who had installed his AC apparatus between Tivoli and Rome.
Gollard and Gibbs had already made headlines 2 years earlier when they first exhibited their invention at the Royal Aquarium in London, but in Turin the system won a gold medal and a prize of £400 awarded by the Italian government. Westinghouse purchased the American patent rights in late November after receiving amicable request from Pantaleone. The Gollard-Gibbs system, although improved by the Hungarian ZBD system, still had serious problems for Westinghouse. This was further complicated by the fact that Edison owned the option on the ZBD, and it was probably to block competitors that Edison purchased the system to begin with. In the same year, in America, after creating the Westinghouse Electric Company, Westinghouse placed William Stanley in charge of the Gollard-Gibbs modifications.
Simultaneously, he brought to America Reginald Belfield, the engineer who had helped install the Gollard-Gibbs system at the Inventions exhibition in London 2 years earlier. Stanley, a frail, thin-faced, temperamental little man with piercing eyes, aquiline nose, wispy moustache, and alfalfa hairdo, was a native of Brooklyn who had worked for Hiram Maxim, inventor of the machine gun. Although it was Westinghouse's idea to place Stanley in charge of the Gollard-Gibbs apparatus, Stanley would later maintain that Westinghouse never fully understood the system until he got it in working order.
This appears unlikely, for it was a private joke among the upper echelon of the Westinghouse company that Stanley had a penchant for claiming new discoveries when they became such to him.
In any case, Westinghouse hedged his bets by establishing numerous DC central stations, as well while research on AC was in progress.
Nervous and agile, Stanley was a hypersensitive individual who never really got along with Westinghouse, due to ill health, and on the advice of the general manager, Col Henry Bilsby, who proposed that success might be more forthcoming if Stanley separated himself from the pressures of the company.
the inventor returned to his childhood summer retreat in the Berkshires in Great Barrington, Massachusetts, to work on the Collard-Gibbs system in private, taking Reginald Belfield with him. Stanley converted the Collard-Gibbs arrangement to parallel circuitry and independent control of separate fixtures, and at the same time created a transformer which stepped up the AC from 500 volts to 3000 when delivered along a transmission line, and stepping back down to original levels when entering households. This invention, although very similar to the ZBD configuration, was nevertheless patentable. It enabled AC to be sent 3/4 of a mile, or approximately 1/4 of a mile farther than the lower voltages of the prevailing DC systems. On April 6, 1886, George Westinghouse, along with Col Henry Bilsby, travelled up to New Hampshire to witness the landmark apparatus for themselves. Prior to coming to Westinghouse, Bilsby had been employed at the Edison Machine Works as a mechanical engineer and was one of the designers of the Pearl Street station. From that time on, Bilsby said, "We progressed with amazing speed." By the time of Tesla's lecture, Westinghouse noted that his company had sold more Central Station S on the alternating current system than all of the other electric companies in the country put together on the direct current system, but few engineers understood the principles involved. In fierce competition with Westinghouse and a third player, Elihu Thomson of Thomson Houston Electric Company, Thomas Edison had received airport on his own alternating current ZBD system. His engineers in Berlin indicated that the use of such high voltages was exceedingly dangerous. Thomson, who himself had lectured at the year before on the topic of AC, supported Edison's contention that AC was too risky. Thus, at the time Tesla spoke, the battle of the currents had already begun, but the makeup of the contenders was complex. In 1886, fully 2 years before Tesla's high-voltage AC system became manifest, Edison had written to his manager, "Just as certain as death, Westinghouse will kill a customer within 6 months after he puts in a system of any size. He has got a new thing, and it will require a great deal of experimenting to get it working practically. It will never be free from danger." Tesla's lecture began with a brief description of the existing diversity of opinion regarding the relative merits of the alternate and continuous current systems. Great importance, Tesla continued, is attached to the question whether alternate currents can be successfully utilized in the operation of motors. He followed this preamble with a lucid description of the problems of the prevailing technology and his elegant solution, explained in words, diagrams, and simple mathematical calculations. The lecture was so thorough that many engineers, after studying the work, felt that they had known it all along. I have the pleasure of bringing to your notice a novel system of electric distribution and transmission of power by means of alternate currents, which I am confident will at once establish the superior adaptability, and will show that many results heretofore unattainable can be reached by their use. In our dynamo machines, it is well known, we generate alternate currents which we direct by means of a commutator, a complicated device, and the source of most of the troubles experienced. Now, the currents so directed cannot be utilized in the motor, but they must be reconverted into their original state. In reality, therefore, all machines are alternate current machines, the current appearing continuous only in the extra-NEL circuit during their transit from generator to motor. Since Tesla's lecture was dealing with fundamentals, it was easily understood, even though his invention was so revolutionary. By demonstration in Tesla's laboratory after the lecture, the inventor showed that his synchronous motors could almost instantaneously be reversed. He also described, in precise mathematical calculations, how to determine the number of poles and speed of each motor, how to construct single-phase, two-phase, and three-phase motors, and how his system could be interlinked with DC apparatus. The lecture made use of entirely new principles. Now electricity could be transported hundreds of miles from a single distribution point, and not just for lighting streets or dwellings, but for running appliances in households and industrial machinery in factories. At the end of the talk, T.C. Martin called upon Professor William Anthony to present his independent tests of the Tesla motors. He had designed dynamos himself, which he had displayed a decade earlier at the Philadelphia Exposition of 1876. Tugging nervously at his scraggly beard, Anthony confirmed that the Tesla motors he had taken back to Cornell had an efficiency comparable to the best DC apparatus. A little over 60, he said, for the larger models. Moreover,
The reversal of direction that the machines could achieve took place so quickly that it was almost impossible to tell when the change took place. End of part to Nikola Tesla and 89 Liberty Street.